Hello, this is Basar. In this tutorial, we will see how we can implement the pagination functionality with the Sequelize in a Node.js application. As usual, we have this code repository and this one for my previous tutorial where we are building the simple CRUD application with the Express and Sequelize and using SQLite. And in that tutorial, we are implementing this branch, CRUD final. And now we are going to implement the pagination and we will build our pagination on top of this CRUD final branch. And the final implementation can be found in this pagination final branch. So you can clone this repository and follow the steps with me. First, let's check what we are going to build. Opening Postman. We have the user's endpoint, which was listing the users in our application, and that was returning the list of users. It wasn't filtering or doing anything. But with this pagination, we will be setting a limitation and we will be able to query just some part of the user list with the query parameters like this page and size. And in this request, we are looking to get the first 3 users. The page size will be 3 and the page index is 0, which means we are starting from the beginning. Let's send our request. Here we are receiving these users. We have this content array and it is saying there are 9 pages. So in the first page we have this user 1, user 2, user 3. The page is limited to what we set right here. And if we set it to something like this, we set it to 5 and now we are receiving 5 users. And now we are seeing the total pages as 5. And if we set the page as 1, we are receiving the next page and it is starting from the user 6, 7, 8, 9 and 10. And if we go to a page where the user does not exist, let's say we go to the page 100 and here we are receiving empty content. So that's how the pagination is working. And this is basically for reducing the payload we are going to return to clients for these kind of endpoints. Like in the applications like the Facebook, the Twitter, there are billions of users, and if they would be having such endpoint for listing all the users, then it would be a huge data which would be occupying lots of resources, and it's not something you would want in your application. So we are going to implement this one. And let's start implementing this functionality. I've already opened the project in the VS Code and let's go over the project. We have this package.json and this application depends on this Express, Sequelize and SQLite. And for the development dependency, we have this node.mon, which is monitoring our code base and restarts our application automatically. And here our script is running the index.js module with this node.mon, and all our implementation is in this index.js. We are initializing the database. We are creating our application. We have this post endpoint, the get endpoint, and all other endpoints for this user CRUD operations. Now we are going to change the implementations for this one. This is get users, which is returning all the users in database. And in this application, our database schema is dropped and created after each restart. So first of all, we need to have some users in database so that we can see how the responses are shaping. So let's start with that. So in this one, we are initializing the Sequelize, which is creating the database and creating the connections to it. And then after the database is up, we are here in this part. We are seeing this message. Now we can create users at this point. So let's do it like this. Let's have a function here. In this arrow function, we will be looping. Let's say we will loop from, from 1 to 25. Let's say inclusive of 25. and this I will be increasing in each iteration, and we will have a user object, and this user will have a username, which will be something like this one, the user I. Then we will have email for this user. Again, this is going to be something like this, and we will have the password for each user, and let's say it is something like this one. And we are going to save this user via this user model we have here. It has this create method, and we pass the user object. This is an asynchronous action, so let's mark our function as async, and let's await this line. So let's save this, and I'm going to run the application. But first I want to remind you that if you just clone this one, first of all you have to run npm install in this folder. Then after all the dependencies are installed, you can run npm start to run the application. So this is inserting user to database, and if I open Postman and send a request, here I'm receiving the list of user. This is an JSON list, and we have 25 users here. Currently these parameters, these query parameters, are not considered. It's just discarded by our application. So the issue is, if we have millions of users, this endpoint will be returning millions of users back to us. So let's start limiting that functionality. First of all, here in this endpoint, instead of this find all, we will use another function, which is find and count all. Let's see what this function is returning back. So saving this one and going back to Postman, sending a request. Here in this response we have this object, and the key is count. It says 25, so this is saying there are 25 users in this table. And in the rows object we have the array, and in this array we have the users from 1 to 25. So we are going to build our pagination with this find and count all functionality. So this one is also taking an object which has the fields we are going to use to limit the results. And the first one is the limit. This is limiting the results. Let's say we set it to 5, and let's see what's going to happen. Going back to Postman. By the way, I'm just removing this part. So just sending a request to these users without any query parameters. Sending the request. Here we are still receiving the count as 25, but in the rows we only have 5 users from 1 to 5, because we are limiting the result to 5. So if we set it to, let's say, 3, and let's wait for the application to restart, and if we go to Postman and send the request, now we are receiving only 3 users. So this limit field is used to limit the result set. And the next parameter is the offset. So this is the value for the starting point for our result. So if we don't set anything, it is going to return first 3 users. If we set offset, the 3 items will be returned after the offset result count. Let's say something like this one, offset is 10. Let's save this and let's try it in Postman. So this is going to be skipping the first 10 users, then it's going to be returning the next 3 users. Let's see the result, and here we are receiving the users starting from 11, and we receive 3 of them, 11, 12 and 13 because we skipped the 10 of them with the offset parameter. So we are going to use these two, and we will be sending parameters in our request to set these values dynamically, because we don't want these values to be static in our code. So we are going to send our request like this. We will be sending page 0 and size 3, and based on the values we have here, we are going to generate the limit and offset values. So first, let's start with this one. We will be receiving these query parameters we are setting right here, this page and size, in this handler like this. This has the request rec.query, and the value is this one, page and size. So we can get the page value like this. So let's say this is page, and we can get the size, request query size. So that's how we can get the values. By the way, instead of assigning the values to our variables like this, we can use the object structuring of JavaScript, and that's how we do it. Page and size are the values coming from request query. So the size is for the limit value we are looking for in the page. So let's use the size for the limit. And the offset is dependent on to both of these two. The page is going to start from 0, like an array index. And 0 will be pointing to the first page, and 1 will be pointing to the second page, and so on. So if we are on the first page, we will be starting from the first user, so the offset is going to be 0. But if we are on the second page, which means the page will be 1, and let's say in each page we will be setting the size as 5, so the offset must be 5. So offset's value is dependent onto page times size. So let's try this one. So going back to Postman, sending the request. Here on page 0, the first page, and we are looking for 3 items, and here we are receiving 3 users. And if I go to page 1, I am expecting to receive the users from 4 to 6, 4, 5, 6. Let's try that, and here we can see it's working. And if we go to the next page, it's going to be user 7, 8, and 9. Let's see that. So this is working. We are properly listing the users page by page. And if we change the page size, let's say we will be receiving 5 users in each page. And since we are on page 3, the previous 2 pages contains 10 users, so our page 2 will be starting from user 11, and here we are seeing it is returning user 11, 12, 13, 14, and 15. So the pagination is properly working. But there are flaws in this implementation. Now we are using the values coming from the user request, and user can set any value they want. So for instance, they can say, let's say the page size will be 1 million. So in that case, currently it's returning nothing because it is looking for the page 2. But if we go to page 0 and look for this size of the page, here we are returning back all the users. So if we allow these kind of values in the query parameters, then the pagination is meaningless. So we must not be allowing user to enter these values. So the user may be looking for the page -1, or maybe they can set the string values which are not number. So in these cases, the application is throwing exceptions. So instead of relying on to what user is sending, let's define a behavior in our application. So let's do it like this. First of all, let's have variables like this one. Let's say page as number. Let's make sure the values are number, so user cannot enter any text for the page value or size value. So for page as number, let's say we are going to parse the value coming in the request query page, and for size as number we are going to parse the request query size value. Now let's say initially the page, I'm just going to remove this one, we will have a page value and it's going to be 0, and we will change it to the value coming from the user by controlling this value first. But let's say the page is initially 0, but if this page as number is really a number, and we can do that control by running number is not a number, page as number. So this is checking if this value is not a number, but we are looking for if this is a number, so we will use not sign here. And the other thing is, if this is a number, then we expect this number to be greater than minus value, so it must be 0 or positive numbers. We can say if this is a number and the page as number is something greater than 0, then we can use that number as our page parameter. And similarly for the size, let's say the size will be initially set as 10. So in each query, by default, we will be limiting our result to 10 users. But if the incoming size query is a number, size as number is a number, then let's check what is the actual value of it. So if this is a number, the query parameter coming from the user is really a number, page size cannot be less than 1. So we cannot be generating responses for zero item per page. So let's make sure we are checking if this size as number is greater than 0, and if it is higher than 10, let's make sure it cannot be exceeding 10 items per page. So if size is less than 10, then our size is going to be the size value sent from the user. So we can merge these checks to here like this, just cutting it from here and adding an and then doing this one. So basically what we are doing here, if this size as number is really a number, and if it is greater than 0, and there's a typo here, we are checking the value of size as number. So if this is greater than 0 and less than 10, then we are going to use the value coming from the user. Otherwise, we will be having this value, which is 10. So in each request, if the user does not send anything, or if user sends an invalid value, which is not a number, which is less than 1, which is higher than 10, then we are going to be using this value, this 10. Otherwise, we are going to use the user's requested value. So let's save this one, and let's try with Postman here. So this is an invalid request for both of the values, but let's see what is the result we are going to receive. And here we are receiving the first page. The list is starting from user 1, and we are receiving 10 users. The default value is applied for our size. And let's add one more thing here. From client point of view, let's do it like this. Let's say we want to be receiving users in, let's say, 20 users per page. let's say we want to receive 9 users per page, and we are starting from this page 0. Now let's go to the next page. Here we are receiving 18. If we go to the next page, we are receiving the others. And if we go to the other one, we are receiving nothing. So we must be telling user how many pages are there in this table. So let's add that too. And we can do it like this. Let's change our response. Instead of returning this result back, this object back, which is having this count and rows, let's return an object like this. We will have let's say there will be a content, and this content is going to be this users rows. So we are taking this rows and returning in an object and in the field of the content of this object. And the next thing is we are going to return let's say total pages, so user will know how many pages are there, and this is going to be a value of users count, how many users are there, divided to the size. So for instance, in our case we have 25 users, and let's say the user did not pass any size parameter, so we will have 10. The size value will be 10. So the result will be 2.5, but the result will be integer, and it's going to be a 2, which is going to be wrong. We need to round this up to the next integer. So we are going to do it like this. Let's try this one, saving it and opening Postman. Just removing the parameters, sending the request. We have the content array, and it is saying there are 3 pages. Let's go to the next page. So we have the users from 11 to 20, and let's go to the next page. This is the 3rd page, and here we are seeing the remaining users, and from client side we can compare the values, the current index with this one, and then show the indicator if we have the next page or not. So with Sequelize, that's how we can create the pagination functionality in a Node.js application. Thanks for watching this tutorial, and hope to see you in the next ones.